The moon is falling. Right now, as you watch this, it's falling towards the earth, and it has been without stopping for 4.5 billion years. That's not poetry. The same force that pulls a dropped apple to the ground reaches all the way up to the moon and pulls in it just as surely. So here's a question almost nobody asks. If the moon is falling, why hasn't it hit us? Why isn't it getting any closer? Isaac Newton answered with a single thought experiment. Picture a cannon on a mountain so tall that its peak pokes out above the sky. Fire the cannonball gently and it arcs down and hits the ground. If you fire it harder, it lands further away, and if you fire it even harder, it lands even further away. But the earth is round, so as the ball flies further, the ground starts to curve away beneath it. Now fire it hard enough and something magical happens. The ground curves away exactly as fast as the ball falls. The ball is still falling, it never stops falling, but it never gets any close to the ground. It just sails all the way around the world and hits you at the back of the head. That is an orbit. An orbit isn't going around. An orbit is just falling forever and always missing the ground. So essentially the moon is just a cannonball that never lands. Good. But what shape does it trace as it falls around us? Ask almost anyone to draw an orbit and they will draw this. A planet on a perfect circle, the sun sitting dead in the center. It's the picture on every classroom wall and on every textbook page. It feels right, orbits look round and space looks tidy. But, sorry to break it to you, it is wrong. Not a little wrong. Wrong in a way that cost one of history's most stubborn geniuses 6 years of his life to uncover. And when he finally saw the truth, he almost didn't believe it himself. Meet Johannes Kepler. Around the year 1600, he got his hands on the finest astronomical data ever recorded. The position of the planet Mars tracked across the sky for decades. Like everyone before him for 2,000 years, Kepler assumed the orbit was a circle. He did the arithmetic, and the circle missed Mars's true position by 8 minutes of an arc. An error smaller than the width of this line. Any reasonable person would have shrugged it off as a rounding error. Kepler couldn't. He trusted the data more than he trusted the beautiful circle. So he tried other shapes, squash circles, egg shapes for 6 years, and finally one shape fit the data perfectly with no error at all. An ellipse. An ellipse is basically a stretched circle, and instead of one center it has 2 special points called foci. And here's the shock. The sun does not sit at the center of the orbit. It sits at one focus off to the side. The other focus, empty, nothing there at all. Essentially, the planet swings in close to the sun, races around, just far away and just comes back, tracing this lopsided loop. And every planet, every moon, every comet moves exactly this way. The tidy circle was nothing but a comforting lie. And Kepler noticed something even stranger. Watch the planet closely. When it swings in close to the sun, it speeds up. When it's just far away, it slows down. It isn't moving at a steady pace at all, but underneath the change in speed, there's a hidden rule of perfect order. Draw a line from the sun to the planet and let it sweep as the planet moves. 1 month near the sun, that line sweeps out a fat, short wedge. And in 1 month far away, it sweeps out a long, thin sliver, a totally different shape, and yet those 2 areas are exactly equal. Every planet sweeps out equal areas in equal times, always. Speed traded for distance in perfect balance. Kepler had no idea why though. That answer wouldn't arrive for another 60 years. But what is an ellipse really? Here's the most beautiful definition, and you can draw it yourself right now with 2 pins and a piece of string. Push 2 pins into a board. Those are your 2 foci. Loop a single loose piece of string around them. Pull it taut with a pencil and drag the pencil all the way around, keeping the string tight. It traces a perfect ellipse. Why? Because the string never changes length. At every point on that curve, the distance to one focus plus the distance to the other adds up to be the exact same number. That's the secret rule of the whole shape. A planet's orbit is just a loop of invisible string, with the sun pinned at one end. Now I want you to pay the most attention to this in particular because this is where it gets deep. Take a cone, not a special cone, just an ordinary one like an ice cream cone, doubled up tip to tip. Now slice it with a flat plane, cut straight across, and the edge you expose is a circle. Tilt the plane a little, the circle stretches into an ellipse. Tilt it further until it's parallel to the side of the cone and the curve breaks open, and that's a parabola that you're looking at. Tilt it steeper still and it splits into two sweeping arms, a hyperbola. So circle, ellipse, parabola, hyperbola, they are not four different curves, they are one shape. A cone just sliced at four different angles. Mathematicians call them the conic sections. And here's the punchline. Every possible orbit is one of them. What decides which? That would be speed. Go slow and gravity binds you into an ellipse, looping back forever. Go fast enough and your orbit opens up into a parabola or hyperbola. You swing past once and you're gone. Escape velocity is just a tilt of the slice essentially. So the ellipse isn't a coincidence. Gravity just forces it. And I want to show you the hidden reason, using a trick the physicist Richard Feynman loves so much that he rebuilt the whole proof just from scratch, just for fun. Forget where the planet is for a moment. Instead, track how fast it's going and in what direction. Its velocity, essentially, and draw that as an arrow. As the planet races around its lopsided ellipse, that velocity arrow keeps swinging around longer and faster near the sun, short and slow, far away. Now take every single one of those arrows and slide them so they all begin at the same point. Watch their tips trace out. Not an ellipse, not a mess, a perfect circle. Hidden inside the wonky off-center orbit is a flawless circle. You just have to look in velocity space to find it. That circle is the fingerprint of gravity's inverse square law. The roundness we wanted all along was real. It was just hiding one level down. For 200 years, Newton's picture was the final word. Gravity is a force, reaching across empty space, tugging the moon into its endless fall. And then Einstein looked closer and said something outrageous. There is no force. Mass bends the space and time around it, the way a heavy ball dents a stretched rubber sheet. And the moon isn't being pulled by anything. It's simply travelling in the straightest line it can, but through curved space. What looks like a loop to us is to the moon a straight line through a bent world, which means the very first thing we said was more true than even Newton knew. The moon isn't held up by a rope, it's falling, following the natural grain of space-time and forever missing. Gravity was never a pull, it's the shape of the stage. One idea. It started with a cannonball on an imaginary mountain. It's the same idea that keeps the space station falling around the Earth every 90 minutes. The astronauts float because they're falling too right alongside it. It's how we fling spacecraft across the solar system, stealing a sliver of speed from every planet they pass. It's the long lonely ellipse of a comet that disappears for a century and returns exactly on time. It's the slow turn of 100 billion stars around the heart of our galaxy. All of it, moons, satellites, comets, galaxies, the same falling and the same missing.